So hi, this is a slightly experimental video in a number of ways, partly because I haven't made one for a while and I've changed my setup, and partly because this is going to be a video about Ruby, which is not a language that I know quite as well as some of the others, but I've been playing with something and wanted to give a quick run through of it. So what I've been playing with is the idea of kind of the simplest possible implementation of the idea of event sourcing for a Rails app. So event sourcing is this idea that you have events that happen to an object, a piece of data, and rather than just directly mutating your data so that you only have the current state, you actually store a history of all of the events that have ever happened to it. We'll have a look at some of the advantages that gives in a moment. But just to set this up, this is the kind of thing we're looking at. So we're looking at kind of a piece of data that's fairly simple. It's a writing exercise for a school because working with No-Red Ink at the moment, and that's the kind of thing we do. So we're storing some data about this school. We're storing the fact that this writing exercise, we know the title that the student's going to submit, the body of the exercise that they've written, whether it's submitted or not, and then we have a couple of boilerplate things from Active Record. So we have a writing exercise ID to link back to the writing exercise because we're storing the state as in a one-to-one relationship with the actual writing exercise, and we'll see why we're doing that in a moment. So this is what we're doing, and what we want to do here is we want to look at the idea of, okay, we want an audit trail of when students did things so that we can show the kind of the progression of the exercise as it went along. So we're going to store a series of events. So let's have a look at our events. They're fairly straightforward. So this is our event. So we've got a few things that can happen in an event. So an event could change a field and it could update the text in that field. So for us, that will be the title or the body. And we've kept that fairly generic because we might want to add more fields later. They might choose to send, they might have chosen to reset their exercise if they've just scrapped the whole thing and they want to start again. So an event might have happened where they've reset it, or the event might have happened that they've submitted it to the teacher. Now, this is that we're using the past tense about these. These are events that have happened that we're storing. So we will get a request to do something from the server, and we'll want to check whether that's a valid thing to do, and then we'll generate the set of events that have happened in response, and then those are what get persisted to our database. So this is just the data that we're storing. So in Rails, for those of you who haven't used Rails before, that sort of happens in these Active Record migration files where we actually specify to the database what we're going to store. Let's have a look at our actual code. So our writing exercise Active Record is where most of the magic happens. So let's have a look. So the first thing to note is that so I've written this little library called Rails Event Source, not to be confused with the much more production ready looking Rails Event Store, which you can go and look up if you want. So Rails Event Source, we're including this event machine thing. We'll have a look at what that does in a moment. But what the event machine needs is a few things. It needs to know what events it's going to be handling. So it's going to be handling these writing exercise events we just looked at. Which field do we want to update? Are we resetting? Whatever. It's also needs to have this has one relationship with the writing exercise state. So that's the actual current state of the exercise. What's the title at the moment? What's the current body that the student's written? And we do that because we don't want to have to go back through the events every time. We want to check, what's the state right now. And this is obviously required. And if we ever delete this writing exercise, we want to delete its accompanying state as well because it's meaningless without it. So that's fine. Now, conceptually in event sourcing, we need to be able to supply a few other things as well. One is that we need to know what the initial state is before no events have arrived. Now, there is a way of doing this in Active Record with a kind of build writing exercise state. We don't actually want to use the built-in version because we will have occasions where we want to do things like ask, what was the state at 3 o'clock yesterday afternoon? So if we do that, we don't want to reset what's in the database. We want to get a new initial state in memory and work from there without kind of updating anything we don't want to. So one of the things is that when we include event machine, we have to specify an initial state function, which will generate a new clean state. So here, our initial state is that this is a writing exercise state that is associated with this current writing exercise. It's got no title, no body, and then we return that state. So that's fine. Then we have this apply function. So we have to supply an apply function. And what the apply function does is it says, okay, if I get a command, a request to do something, should I do it? And if I do, what events have happened as a result? So we've got a few commands here. So one of our commands is that if we get a command that says update a field and the field is title, and there is some text available, then let's update the title field with the text. Same for the body. If we get a reset command, then we want to issue two events that have happened, because we want to issue an event that says, well, the title should be empty now. We want to issue an event that says the body will be empty now. So we actually release two events as a result of this one command coming in. If you notice above, even the single event ones, we're actually returning a list. And finally, we have this idea of, well, the student tries to submit it. Now, this isn't really an error. This is a valid command to try and send, but it's only valid sometimes. So we actually check first whether they've put in a title and a body. And if they have, then we issue an event saying, hey, they've submitted their work, it's done, it's finished. If they haven't, we don't actually update the local state at all. We just treat that as a no-op, and we, in a production system, we might want to log something here or something, because that's just our UI is not really giving them the options it should. And that's great. So we now know what's legal, and this the idea of the event sourcing is that this apply function becomes very restrictive. It should only do things it really knows it should be able to do. And as you can see, because it's on the because it can access the current state of the current writing exercise state, it can check whether things are legal as they are now. And we'll get down to what now means in a moment. And finally, we have this fold function. So this is actually the logic of, okay, I found some events in the database, or some new events have just been created as a result of a command coming in. The fold command knows how to take a current state and an event and return the updated state, depending on what that event is. So we actually only have three valid types of event. We can have an event which updates the title, we can have an event that updates the body, and we can have an event that submits the writing exercise. And if we come across anything else, here we don't want to throw or raise an error if we get an event we don't recognize, because actually this is something that it's not something the user's done wrong. This is, we have stored these events into the database and we should be able to handle them. So again, we might want some logging here if we get something that isn't an event we recognize, but we really don't want to throw. We want to try our best to deal with the data we have, because the data we have is the data that's stored in the database. So that's all great, but we are relying rather on the fact that we want certain things now to happen, and we want to be able to do them reliably. And this is what Event Machine does for us. So let's now actually have, having looked at our example, let's have a look at how Event Machine itself actually functions. So I'm not going to claim this is the pinnacle of Ruby programming. I'm fairly new to Ruby, and it's entirely possible there is mistakes in the transaction logic here, but this is to get across the idea and was partly a learning exercise for me. So let's have a look. So Event Machine is a class that's designed to be included within other classes, and so it makes use of this active support thing to make that simpler in Ruby, the sort of meta-programming side of things. And so we do a few checks when it is actually included into another class. So one of the things is we're going to rely on a whole load of the active record methods to be doing things. So we actually check whether the thing that's trying to include us is an active record. And we also say we want to do some initialization. And basically our initialization callback is after all the active record stuff has been set up and initialized. Two things might have happened. One is that we might be an existing record that's being loaded from the database, in which case we're fine, we'll have a state, we'll be loading that. Or we might be a brand new record, and if we are, that's where we make use of our, the first time we make use of our initial state function to generate a clean new state and set that as the current state of the active record. So that kind of happens in the background for you. You don't have to worry about it, which is quite nice. Now, the most important thing we then want to be able to do is we actually want to be able to process commands, and we don't want to have to worry about sort of the locking and things. So Event Machine gives us a process command function, which we give a command, and what it does is it actually opens a transaction, and it does a few things. So one is that it actually both reloads the current state from the database and also tells the underlying database provider, lock this row. If anything changes this state before we're finished, we want this transaction to fail and we want to roll everything back. With our newly reloaded state, we then call our apply function, which we have to supply. So that's one of the things we supplied on our writing exercise. We call the apply function with a command. We check if there's any events. If there aren't any events, we're done. That just means that whatever the command is, it's a no-op. We don't care. If there are new commands, then what we do is we use this inject function on the array, which those of you from other languages may have come across as fold. But basically, all inject does is it takes an initial state, it's a function on the array, then takes an initial state, and for each item in the array, it updates the state based on the next event coming in. So this is where we make use of our fold item. And then within this same transaction, we write all of these new events to our event stream, and we save our state. And if all of that's successful, the transaction carries through, everything gets written as an atomic unit, and we're good. And if anything else has changed the state in the meantime, this very last command will cause the transaction to fail, everything rolls back. So that's how we update our record. So we're never directly messing with the state. We're always going via the event stream. And this seems a little bit roundabout, but it immediately gives us a couple of other things that we can do very cleanly as well. So one thing is that we can do things like load at a specific time. So for a writing exercise, this might be something like the teacher set a due date of Wednesday morning. So what we can do is we can say, well, actually, let's load what the state was at Wednesday morning. Was it submitted then? And what this does is this again makes use of our initial state function to get a new clean state. And then it goes off. I've just noticed that line shouldn't be there actually. Then it goes off and gets all of the events, and it just does a fold in memory of the events up to the time where we wanted. So we're hoping here this isn't a huge list of events, but a relatively short one. And the other thing we can do is we can say load the state of load the state at a particular event in the stream. After 10 events, what had happened, and so that can be good for different things as well. And especially if we start taking advantage of Rails's authentication system, then it obviously becomes trivial to do things like ask questions like who did this change and when did they do it and what was the effect. So that can be really powerful as well. And the final thing that we can do quite easily as well is that if we ever want to at any point, I haven't actually implemented this yet, but the final thing we can do is that if at any point we change our fold command, then we can easily throw away our old state and rebuild it with the new fold command. So that gives us quite a lot of power for changing how we handle our state as we go forward and doing migrations to newer, more powerful kind of data structures as we go forward based on the same historic events that have happened. So just to give you some ideas, let's have a look at the, whoops, press the wrong button. Let's have a look at the specs. So this is the kind of thing it allows you to do. So, We can add events to our event machine. So we can say we want to create a new writing exercise. We want to process a command to try and update the title. And then we check that the state actually has an updated title. We can obviously do multiple commands. And then more interestingly, we can do things we can say that we would like to update the title twice, but we actually would like to check what was the title before. Oh, I'm going to load up to event number 1 and see what the title is. And we can do playing with the rather powerful and useful timecop library here that messes with Ruby's built-in date time. We can say, okay, we're going to pretend that we wrote an event at a particular time and another event at another particular time. And then we're going to say, okay, if I load it in between, I should be able to check what the state was historically. So that's about it really at the moment. That's what I wanted to demonstrate and what I wanted to show. And I just wanted to have a look at kind of how simple some of these ideas are to get going, even in other languages. So this is largely based on the fact that I looked at an F# version of event sourcing recently, and people were asking, yeah, but we're using Ruby on Rails for some of our bits. Can we use that as well? And the answer is yes. This is roughly what it looks like. And also just looking at the fact that yes, you can go event sourced for a full system, and that does give you advantages, and you can read a lot about that kind of thing in the background. But I think it's kind of something useful to be able to event source just sort of individual data items and have a look at taking advantage of it in the very specific places where you need it. And that's perfectly viable too. And even here, here we've got a state object that's being updated by the events, but we could also be storing other data on our writing exercise that we don't care about the audit record of. We don't need to be able to do sort of time traveling on, and we could just store those as normal active records fields and everything would carry on working. So that's all for today. I hope you've enjoyed this brief excursion into Ruby, and hopefully I will see you some other time.